Now we'll start our second part of Chapter 22, and we're going to start with fire station tours. We do a fair amount of fire station tours, and typically this will happen through the month of October during Fire Prevention Week, but we also do them throughout the year. And these could be small groups from preschools and school-aged children to groups such as the Boy Scouts or a Girl Scout troop and other groups will come and do fire station tours. And one of the big things with this is an opportunity to enhance the department's image and to provide fire and life safety messages while we're in our own house. And we're able to distribute safety awareness literature in the same manner, in the very same literature that we're giving out at the schools and in other functions that we may do. Sometimes this may be spur of the moment. Visitors may stop by, and because it's a fire station and they may see the doors up. Oftentimes in the summertime, we'll have the doors up. People will walk by and with children, and they'll want to come in and see the fire trucks and visit for a minute. And then there also may be scheduled groups that come in. And we certainly are more prepared for the scheduled groups, but it is a good idea to keep a certain amount of extra literature, handouts, and those kind of things for the spur of the moment visit. Tours of children are often common again during Fire Prevention Week, and this is probably where we have the most traffic in the firehouse for this particular reason. So how do we prepare for this? One is to confirm the age of the children, the number in the group, along with the number of adults, and then schedule your time according to time available. And then we kind of want to know what is the expected message. Oftentimes a fire station tour, the group will want basically to see the equipment, to talk to the firefighters and see the station, and then within that small amount of time frame, we can integrate into that time the message that we want to send as well. So decide on and receive approval for station areas to show. You always want to keep your station clean and tidy, especially more personal areas such as bedroom areas. It's just a good idea to keep things neat, bunks made up ahead of time and that kind of thing. When you do get the spur of the moment visit and someone they do want to see the living quarters of the station, you're able to do so, and you don't have to worry about a mad rush going through and cleaning things up. Check to see that the areas are clean and orderly. Oftentimes we have people in the public want to use the restrooms as an example. They feel safe, they know they could stop at a fire station to do that, so it's a good idea to keep everything clean. We want to provide a designated place for children where they can leave personal effects and coats, a coat rack or something like that as well. And then again, designate a bathroom that may be used by everyone, including children, and inform the station personnel when the tour is scheduled or when a group arrives or leaves. So we got to round people up because people may be dispersed within the station. Some may be studying for promotions, for an example. Some may be working on things in the bay or in a utility room or at the workbench. And so we want to round everybody up, get the group together so everybody can see the group, and just explain how the day goes and how everybody functions in the firehouse. In preparation also, we want to ensure that apparatus is clean and it is easy to access. Unless it is, most firehouse policies is unless it is raining out, actively raining, we'll keep the apparatus clean and washed. If it's raining, we'll rinse them off. But you could wash a truck 10 times on a rainy day and never have it clean if you have to keep going out. Supervise anyone who is allowed to climb on or get in apparatus. So this is something where you want to post a couple firefighters to help kids in and out of the truck, for an example. if you have an ambulance and you allow them to do a brief walkthrough, you want to limit what they can touch basically inside of an ambulance. It should be clean, but we want to make sure that they're not touching anything that's red that is marked sharps and those kind of things. So you have to have somebody there to give direction. Follow any SOPs for the civilian access of apparatus. Some SOPs do not allow civilians in apparatus or even in the cabs to sit, so they have to, you can then get the groups together for individual and group pictures is a good way if your SOP does not allow kids or civilians in your fire apparatus. Ensure that protective clothing is clean and safe. So oftentimes we demonstrate protective clothing, the wearing of protective clothing, and in doing so, we want to make sure that everything is clean and that we're not going to potentially contaminate somebody with dirty gear. Set aside the handouts near to the end of the tour, and a lot of times especially with school groups, we will give the materials and the handouts to the adult that's in charge, whether that be a parent or a teacher, whoever the leader of the group is. And one of the things we do, typically we will have a goodie bag that it'll have literature in there. It will have, depending on the age of the group of children, it may have a coloring book, crayons, there may be a plastic fire helmet, some things like that, or goodies as we call them, to give them. And we will give them to the teacher or the adult and let them hand them out at the appropriate time. That way they're not, if they walk to the fire station, whether it be from the parking lot or up the street, they're not chasing, fire helmets in the wind and that kind of thing. Decide where your tour group should go if an alarm sounds. And this is something that you want to explain early on. You do your introductions and then just explain that if you were to have a call while the group was there, where everybody goes and where we can maintain accountability. The last thing you want is a missing child when apparatus is moving out of the base. So decide where the children will go. Clear this with the officer in charge so everybody basically is aware, and let the adults in the group know and explain that to them. Before the tour, explain to the adult that you will escort them to those safe areas basically, and then we will allow apparatus to move. Instruct your group leaders on what action to take once the units have cleared the station. Civilians at the fire stations, firefighters should dress appropriately and conduct themselves with courtesy and professionalism. This is something that we should be doing at all times. There are times throughout the day, depending on the day of the week and whether it's a holiday, situation or not, that we may not have dress, clothes, or we may not have polos. We may be in t-shirts and work pants and that kind of thing. But when we do have visitors, we want to put on nice attire, nice polos with a collar. It does not have to be a dress shirt, but a lot of departments will require a dress shirt without a tie or a Class B type uniform. Firefighters make strong impressions on the visitors. How we speak, how we dress, our appearance, all that matters. At this point, when we know we have visitors or a scheduled group arrives, all televisions should be off, activities should be on the positive note, and we should present basically a professional workplace type atmosphere at all times. Again, provide safety instructions at the beginning of the tour about what to do if an alarm sounds and we have to go on a call. Pick those safe areas and explain that to the adults of the group, and then explain how to exit the building once we leave. During our fire station tours, answer all questions courteously and to the best of our ability. If there is a question that arises that we're not real sure the answer, Don't be afraid to say that you don't know, but we'll find out, and we can either get back with you, or hopefully we can find out the answer before the tour ends. Fire and life safety information can also be distributed. This is where the literature and the handouts that we get during and we keep during the year that we can hand out. Some departments do allow visitors to climb on apparatus or to don equipment, but many do not. And I will say again, as a word of caution, if we allow anybody other than us to don equipment, such as PPE, then we need to make sure that it is clean. A lot of departments these days are not allowing civilians to put on gear, but they will allow one of the firefighters to do so in order to demonstrate that. Visitors should never be allowed to roam around unescorted. There's things in the bay of the firehouse that people can get hurt on if they don't understand how a piece of equipment works. And there's personal items in parts of our fire stations that visitors just don't need to have access to, whether that be personal computers and other personal items that firefighters bring to work in order to study and to have during leisure time. These are things that visitors should not be allowed to be around unescorted. Oftentimes we do find ourselves um, with groups, and it's really good to designate one person to lead the tour, and then you can break that tour or bits and pieces of parts of it down to different firefighters. Usually what you'll find is you'll have one or two people that are really good at talking to, especially children and young adults, and that's the person that you want really leading your tour. Equipment and apparatus should be demonstrated with caution. Again, we need to realize that the group that we're demonstrating these things to are not aware of a lot of this equipment or how it works. Positioning firefighters at strategic locations help prevent visitors from straying into restricted areas or hazardous areas. We usually do. We'll have uh, a firefighter or two leading the group, and we'll have a couple firefighters that are at the end of the group following, and that's to make sure that we don't have any children or anybody stray off into an area without the rest of the group. And then we'll also may have firefighters staging in certain areas as we walk through to begin an explanation of that part of the station. Many departments again prohibit taking visitors up on elevating platforms of aerial ladders. A lot of times we won't pull apparatus out and set up a ladder. There might be times that we have a ladder truck out in the public doing certain functions, and you'll get the question, can we climb the ladder? And we always decline that. Climbing aerial apparatus is a dangerous prospect for us, and we certainly don't want civilians that are untrained, going up your ladder. Exercise caution when activating sirens in the presence of visitors. Our sirens, especially Q sirens, are very loud. You have 100 and 200 watt speakers on your electronic sirens, and even air horns. If somebody's in front of those air horns, they're very loud, and you can cause somebody to have ringing ears, a situation that could be permanent. So we don't want to activate. We usually don't activate those in the bay as anyway, so you wouldn't want to do that with people standing in front of those speakers. Station mascots can be safety and liability hazards as well. Uh, Many years ago, fire departments had dogs, station dogs, as a mascot or a pet, and a lot of fire departments got away from this because, especially because Dalmatians tend to get, as they age, they get testy because the breed of dog will lose their hearing early on, and so they kind of get mean or testy, if you will. And a lot of departments stopped using dogs, and we're now in a time that we're beginning to bring station dogs and other animals back as comfort animals for the firefighters and to help de-stress. So if you do have a mascot in a station, then have a plan for that particular animal, whether the animal gets put up during the tour or is a part of the tour, and there should be a specific handler with that animal. Next is we're going to talk about the process of conducting and documenting pre-incident surveys. And these surveys are pretty important because we go to these businesses, we go to these areas that could be, target areas or problem areas or hazards in your response district. And so knowing and pre-planning things ahead of time can really help us out when we have an incident occur. We want to allow personnel to gather information about occupied structures before an emergency occurs. That's the purpose of this, basically. And some of the things that we're looking at, we want to this can help us with locating and controlling fires, possibly locating occupants. Determining potential hazards is one of the big things as well. Improving emergency operations and improving firefighter and occupant safety. During these surveys, firefighters document details about the structure. We may use maps and drawings, take photographs, and then otherwise write down notes. Some of the things that we want to know about during our documentation is we usually start with the outside, and we want to know the type of construction. Is it type 1, 2, 3, 4, or 5? What that type is. We try to obtain a floor plan or a layout. A lot of times the occupants, the business owners will have a digital floor plan, if you will, that they can email us. If not, then it's up to us to draw out a floor plan on a piece of paper. So it's good to have graph paper with you if you can as well. We want to know the contents, what things are being stored and where they're at. What type of occupancy is it? Is it a business, warehouse, apartments, that type of occupancy. Hazardous materials, any storage of those, and warning placards, signage, and where these materials are stored and kept and what they're used for. Any special processes that may be on the property, we should be noting. And then fire detection and suppression systems. Do they have a system? Where are your shutoff valves? Where's your connections? Those kind of things. Any fuel loading? What's being stored, where it's being stored, and is it normal for that building? Fences, gates that may obstruct our access, and do we have a way to get through those gates and fences? Documentation of our pre-incident surveys helps us to, one, become familiar with structures that are in the district, what they're used for, and any of the associated hazards. We can begin to visualize how standard tactics may or may not apply to these buildings. We then can begin to develop new tactics if necessary, or alter, tactics that we already may have in place. Determine if the occupants have disabilities or medical conditions that prohibit them from getting out on their own. This is a big issue, particularly in apartment buildings and structures. And what can really hinder operations is people that have disabilities that can't get out on their own, that are going to need help. You find yourself helping these folks out right away at the same time you are trying to mount firefighting efforts. And then we want to determine if there are any occupants with language barriers that may need translators. Pre-incident surveys and code enforcement inspections. The same personnel are going to be conducting both because most departments require both of these functions in one visit. So you may find yourself doing, both roles, filling out both documents. Some departments will separate them out. They will do pre-plans throughout the year, so many, and then their normal inspections will be a separate appointment, in a separate time. This can be done either way. Pre-incident surveys are conducted to become familiar with the structure, basically. Oftentimes when we do these surveys, we do note things that we see that might be problematic, and we will point that out to, the building owner or the occupants in an effort to get them to, fix the situation. When we're doing the inspection itself, we actually document those findings. It gets written down, sent to the fire chief or the fire marshal, and then in a notable time we will come back and reinspect that. So there's a little difference in the two. In our inspections, we want to verify again that the owners and occupants have complied with the codes, and that we do that by giving them a reasonable amount of time to make the corrections and then come back and do a reinspection. If code violations are discovered during the surveys, the officers may request that the owner or occupant correct a violation and report the problem to the fire inspection and or code enforcement division. If it's bad enough, yes, we'll report it during this phase. A lot of times you can point things out and they'll fix things right, right before you leave on the spot. With our pre-incident surveys, we should not be surprising anybody with a visit. So these are areas that in surveys that we should be making appointments for. Companies assign based on predetermined cycles. So usually every so many years we do the surveys, or any time a business changes hands and it changes what type of business is there, we will come back and revisit that pre-plan. Surveys that occur when a structure is remodeled, or again it changes the occupancy type, they can go in and change the layout. I mean, knock out walls, put in different walls for different reasons, depending on whether it was a business or, an occupancy. And because these things change, that's when we know they get remodeled and we know those uh, business fronts change hands, then we do want to come in and take a look just to familiarize ourselves with any changes that may have been made. Inspection and Code Enforcement Division may notify companies when the structure should be visited, so that they're keeping track of how long it's been since the last time we've been there, for an example, and is it time to go back. As a firefighter, we're part of the team under supervision of the company officers, and then we rely on SOPs to establish the procedures for those surveys. General steps of our surveys. First step is to contact the occupants or the owner before we arrive and set up that appointment, basically. Then we want to meet up with the owners and occupants or their designee upon the date and the time of arrival. We'll begin the survey on the outside of the building. We'll begin to make preliminary notes and sketches of the outside, and then start taking photographs if they have granted permission. Usually with the photographs, especially on the outside, we're looking for, is there a hydrant close by? Can we determine, the water supply? If there is any limitations in how much your hydrants flow. Are there sprinkler connections? Where are they located? We're looking for exits, entryways, windows, how many stories. Can we get apparatus on all four sides of the structure? Those type of things. Use detailed site plans of the exterior from previous surveys as well. We just remember things can change on the outside, such as landscaping. Parking lots can be changed around, buildings can be added, adjacent buildings and those things. So This is what we want to update and we want pictures of. So we locate the primary and secondary entrances. We'll note any windows and doors that are covered by security gates or grills. This is something that in certain areas is common, and we want to know that they're there and note that they're there, and that will give us prep time to prepare how we would deal with it. Are we going to cut them away? Can they be pried away? That kind of thing. Next is locating the utility shutoffs. While we're on the outside, we want to look for, does it have gas? Where's the meter and shutoff? Where's the water, shut off? And then where's our electric service coming in at? We'll note the location again of fire hydrants, fire department connections, water control valves, water supply source, and fire control room and alarm panels. So we want to write down the construction type, height of the building, occupancy, and proximity of any exposures when we're on the outside. Conditions for planning apparatus, response, and positioning. We're looking for, again, is the property accessible on all sides? What are the street conditions? And how close can we get? And does it allow for collapse zones? The distance from the street to the building, basically. Barriers to any aerial device operations, such as overhead obstructions, overhead power lines, and those kind of things. Landscaping, water features, and topography that could make access more difficult. This is something that we should note. And overhead obstructions again, and power lines that would restrict the use of ladders or aerial apparatus. When the exterior survey is then complete, the team should go to the roof or the basement and then proceed with the rest of the survey in a systematic way. If floor plans and drawings are not available from the owners or occupants, firefighters may be able to obtain them from the inspection previous plans, or we may be able to obtain them in electronic format from planning and zoning. If that's not possible, then we do want to make a rough sketch as we go along. That way that we can, go back later and make a better drawing. Drawings and photographs of hazards and of unsafe conditions. Draw or photograph interior layouts, high hazard areas, and important features. Record any changes that have been made. Update the floor plans and drawings accordingly. Drawings are important when developing written pre-incident plans or using computer-aided dispatch. The dispatcher can bring this up on the computer and give us a heads up, or we can look at it on our own data terminals and bring those plans up and look at them while we're responding. Complete any notes, photographs, and drawings. Provide dependable information for your report. Large or complex buildings may require more than one visit. Different buildings should be surveyed separately, and starting on the roof of the highest building can provide an overall view, and you may even be able to take an aerial photograph to help you, get that relationship to the adjacent buildings to the tallest building. If any hazards are found, the owner or occupant should be informed and asked to correct them. Information should also be provided to Inspection and Code Enforcement Division. So if you see major things that are going to be issues even during a pre-incident survey, it's a good idea to note them in your notes and forward that information to Code Enforcement or the Fire Marshal's office. They may want to come back and just have a look. Information provided to operational units. Any changes again in the floor plans, use or processes, any access, and the changes in the occupancy status. When information discovered during operations differs from an existing pre-incident survey, then reports from the scene can be used to update or generate these surveys. water supply sources and FTC connections. Uh, we want to know about the water supplies that are near the facility. We want to know about any hydrants, any potential drafting sources such as ponds, maybe swimming pools, things like that, and any fire department connections that are available. Unsafe conditions. They may arise from the design or the use of the building, facility, or equipment and may be related to behaviors or certain processes. Usually that's the case. May be specific to a certain type of occupancy or found in all occupancies, and they may result from mechanical failure, damage to equipment, or a certain environmental condition. Some of the things that we're looking for when it comes to the local codes and standards, our job is we note these to reduce potential unsafe conditions. And so we're looking for electrical hazard conditions. This could be improper wiring. This could be extension cords that are used for permanent wiring, which you see a lot. We see you might have breaker panels that are having problems that need to be in repair. Covers, on electrical outlets and switches and panels. Material storage facilities. What's being stored and what kind of fire load these can be, and how things are stored, especially how clutter and trash is stored. HVAC equipment and systems, we want to know where they're at and how to operate, how to shut down that type of equipment as well. Any cooking equipment, cooking hoods such as in restaurants and catering businesses, you want to make sure that their extinguishing systems have been inspected properly and everything is in working order. And then you look again at the housekeeping and the cleanliness of those areas and that equipment. Any industrial furnaces or ovens as well. Any loose stairway handrails. Handrails in general should be tight. They shouldn't wobble or be loose. Ice on sidewalks and exterior stairs during a visit. Any unsecured swimming pool access, and any non-working smoke detectors. Usually we'll test emergency lighting as well if the building is equipped. One of the common things that you'll find is emergency lighting for exits. Bulbs will be burned out and the batteries may be dead in your emergency lighting. And these are common things. When we see them, note them, write them down, pass that along, and let the occupant or owner know. That way they can get the things to fix them. Recognizing hazardous processes. These processes may exist temporarily or be a constant function of an industrial or manufacturing type sites, such as welding, cutting, grinding, painting, and dry cleaning. Enforcement of codes, periodic inspection, and education work together to reduce these hazards. A lot of places that have these processes in place understand, realize the hazards, and usually do a pretty good job at keeping these hazards down to a minimum. Recognizing our alarm systems and panels and functions, we want to notifying occupants to take necessary actions to escape. So the fire alarm system functions detect the presence of fire or the products of combustion such as smoke or heat. They may be summoning organized assistance to initiate or assist in fire control initially if that is something that is doable at the time. It may be initiating automatic fire control and suppression systems and sounding a local alarm as well as an alarm that's being transmitted to the fire department or an alarm company. Supervising fire control and suppression systems to ensure that the operational status is maintained. Operating ventilation systems to remove smoke and other products of combustion and they may include initiating auxiliary functions that involve environmental utility and other process controls. Components of your systems: your fire alarm panel, which contains electronics that control and monitor the fire alarm systems. Basically, these receive signals from initiating devices, processes the signals, and then produces output signal. It gives either a local or both a local and alarm to alarm companies. Primary power supply to these systems usually is the building's main electrical supply. If it gets interrupted due to loss of power, a trouble signal usually is indicated at the panel, and there is a battery backup for that panel. This is another area in these type of systems. We'll see that the batteries do not function properly, and so they simply just need to be replaced. Your secondary supply must be provided to ensure the system operates when the primary electrical systems fail. And again, this usually includes batteries with chargers, or it could also be auxiliary generators. Initiating devices: this could be your manual pull stations or an automatic smoke or heat detector. Automatic devices sense products of combustion such as smoke or heat or hazardous conditions, and then it sends a signal to the panel. Notification appliances: once initiating the device signals to the panel, then the unit processes the signal and activates the notification appliances. Okay, so this could be audible, visual alarms. Your audible alarms is a sounding device such as bells, speakers, horns, or sirens. Visual are lighting devices such as strobe lights or flashing lights. Textual is visual text or symbols, and then tactile, touch, or vibration type indicators. A lot of your modern fire systems will talk as well. Fire command center: in many large buildings and high rises, you'll find a center or a room that has all the information, the panels, everything you need to know, and even controls for the HVAC systems. It consolidates fire protection system controls all in one location, so you don't have to go send people all over the building. And it allows various systems to be monitored and or controlled from that one location. In your fire command center, you'll have items that will include, or you'll find there, such as the alarm panel, smoke control stations. It may be able to control fans and pressurize certain areas and turn off fans or air handlers, or have control of the HVAC system, if you will. Fire pump status and indicators: if the building in the system is equipped with fire pumps, are they running, and which ones are running if it has multiple pumps. Emergency elevator controls may be present there as well. Emergency communication systems, intercom and speaker systems and telephone systems are usually installed in these buildings and can be used. You'll find the extra handsets that can be plugged into various places as well. Any spare sprinkler heads and fuses, and then any building plans, system diagrams should be located in this area. Protective premises systems provide notification only to the occupants on the grounds, basically. These can be manual or automatic initiating devices and may be capable of enunciating a supervisory or trouble condition as well. There's non-coded, zoned, enunciated, and addressable types. In the supervising station alarm systems, these monitor remote locations to report supervisory, trouble, or alarm signals to the appropriate authorities. These could be proprietary systems, central station alarm systems, and remote receiving systems. Recognizing fire alarm initiating devices: we identify the presence of fire or products of combustion. So they're going to identify smoke or heat or the rate of rise of heat, then we'll send a signal to the alarm system or the alarm panel. Manual can allow occupants to activate the system, such as pull devices, one of the most common. Automatic would be designed to detect products of combustion, such as heat, smoke, fire gases, flame, or a combination of these. Most familiar to us are manual pull stations. These are required to be read with white lettering. They're required to be mounted at a certain height and visible and not blocked. This allows occupants to manually initiate the signaling system. They may be connected to the systems that sound local alarms, off-premise alarm signals as well, or both. Heat detectors may be fixed in this system. They can be fixed to a specific or known as a fixed temperature. Say they're set at 500 degrees Fahrenheit. Then that's when it reaches 5, that's going to alarm. And it could be rate of rise. So the detector is detecting what rate did the heat change and how drastic did it change. You'll find these in application in areas that do produce heat. So there may be a process that it's producing heat, and it's when that normal change of rate of rise, changes to something very rapid. For an example, then you might have that application in those areas. So that's what a rate of rise is. Smoke detectors and alarms basically will detect the presence of smoke or other products of combustion. With your smoke detectors, they're only capable of detecting, they must transmit the signal to another device that then sounds the alarm. And this is installed in non-residential and large multifamily residential occupancies in most cases. Smoke detectors, again, they detect, they send that to the panel. The panel will then set the alarm off. With smoke alarms, they're self-contained, capable of detecting smoke and sounding an alarm. Typically are installed in your single family dwelling or smaller multiple or multi-family residence. So this is what in America is now required in modern or new residential construction, and it's been required for many years now, that you have smoke detectors in specific areas in the home and that they have battery backups and hardwired operation. It is recommended that they are changed out every 10 years. With your smoke detectors, these could be photoelectric detection, sometimes called visible products of combustion detector. They work well in all types of fires, usually respond more quickly to smoldering fires than an ionization type detector. So our other type is ionization. These type of detectors will detect particles and aerosols produced during the combustion that are too small to be seen by the naked eye. So a lot of these, even your smoke alarms, the detector in those alarms in the residence have an ionization process. You'll not see any visible smoke, but it can still set the alarm off. This is kind of an explanation on how your photoelectric detectors work. When the products of combustion and specifically the smoke breaks that beam, uh, then because they have a light source inside there, that will trip the circuit to send the signal. Um, a refractory application of the photoelectric, you've got the lamp and the lights that's bouncing these beams. Again, when there's a disruption in those beams or light, then that sends the signal from the photocell. Ionization, you've got electrical particles that are with this electrical charge that are going back and forth between an anode and a cathode. Basically, when that gets disrupted, then the signal is disrupted. You're breaking the circuit, if you will, that will then trip and send the signal to the alarm. These are there is radioactive material that's causing the alpha particles to go, back and forth. Power sources for our smoke alarms, these can be regular household current, and they can be battery operated or both. A lot of detectors in the home in new construction are required to be on household current with a battery backup. So if the power does fail, or when it does fail, these alarms will still operate. With batteries, they should be tested every month and replaced once a year. Newer alarms may have what's known as the lithium battery, and these do have a 10-year shelf life. And there is printing and stickers on the detector itself that lets us know that it has a 10-year battery. Alarms that are under household current, some codes may require alarms in newly constructed homes that do specifies they have to be 110-volt hardwired units with battery backups. This is pretty much across America. This is the universal building code for smoke alarms. Usually they are very reliable. Some, again, may have battery backups. Just about all of them that you're buying today will have a battery backup. Flame detectors, they're very fast to respond to fires. Non-fire conditions may initiate false activations. However, usually they're located in areas where other light sources are unlikely. Positioned to have an unobstructed view of the protected area, sometimes they're known as or called light detectors. These can be UV detectors, light in the ultraviolet wave spectrum, or infrared detectors, light in the infrared wave spectrum. Some flame detectors are equipped to detect light in both the ultraviolet and the infrared spectrum. Fire gas detectors. Fires in confined spaces release water vapor, carbon dioxide, carbon monoxide, and other gases. For general detection purposes, it's practical to monitor carbon dioxide and carbon monoxide. This initiates the alarm signal faster than a heat detector, but not as quickly as a smoke detector. They can be more discriminating than other detectors. These are usually specific to a specific gas. Combination devices are more versatile and responsive to fire condition. Your fixed temperature rate of rise heat detectors can be combined with smoke and heat detectors, as well as fire gas detectors. Automatic sprinkler systems. Recognizing this, we have pipe sprinklers and control valves. The combination of these automatically discharge water or extinguishing agent to extinguish a fire or to prevent or help prevent the spread until firefighters then arrive. Sprinkler arrangement and coverage usually are arranged for adequate distribution. They can extend from exposed pipes or protrude through the ceiling or walls from hidden pipes. There can be complete coverage or partial coverage. General causes of a system failure: partially or completely closed main water control valves. It's just like with anything, a partially closed or partially open valve does not allow all of the flow that valve should allow. That can cause you problems. Interruption to the water supply itself can cause a system failure. Damaged or painted over sprinklers and sprinkler heads can cause them not to work or function properly. Frozen or broken pipes, probably one of the most common ones that we encounter and see are frozen and broken pipes. We get this in the wintertime. You'll get a deep freeze. Um, Temperatures will be well below freezing, even near zero, And it's when the warm up occurs is when you start getting the alarms, because it freezes, it will bust the pipe or a component in the system, if you will. And then when it warms up, everything begins to leak and thaw out, leak, and cause water flow. This is when you'll get the alarm for it. Excess debris or sediment in pipes from the water system can cause problems. Failure of the secondary water supply, pumps, fire pumps, and things like that. Tampering and vandalism. Uh, One of the reasons why with our control valves and PIV valves that are on the outside and wall indicator valves, we chain with breakaway locks to reduce vandalism and tampering. And they may have tampering devices on them. So if somebody were to try to operate the valve, it will send the signal to the panel and cause the alarm to sound, which would summon the fire department. Objects that obstruct sprinklers as well. And the big thing that we see here is storage areas. And what'll happen is they will stack debris, material, merchandise, boxed merchandise could be stored and stacked too close to the head itself. And if it were to operate, it would basically block the pattern and would not be able to do its job effectively. Components of your sprinkler system. In a wet pipe system, you'll have your water main and control valve, a riser that will bring water up to your feeders. You could have a main feed and cross mains as well, and then in those you'll have your closed sprinkler heads throughout. Somewhere in the riser there'll be a test connection so everything can be tested. With your sprinklers, they may be fixed spray nozzles that open individually. Open sprinklers with no heat responsive element can be encountered, especially these are usually found in a deluge type system where they don't, all the heads are going to flow at one time if the system is activated. Early suppression fast response sprinklers react 5 to 10 times faster than the traditional sprinklers. They're easy to identify. They are larger than traditional sprinklers. Your heat responsive element activates, the cap or the plug opens, and then the water is then discharged. Sprinklers are commonly rated and identified according to the temperature at which they are designed to operate. Oftentimes there are color coding on the frame and the arms of the sprinkler. The color coding in liquid filled could be the glass, the color of the glass bulb that the liquid is in. Stamping of the temperature into the sprinkler, the arms, or the head. Here's what some of them look like, commonly used. On the top left is the fusible link. And basically there's a link in here that is set to melt at a certain temperature, and when it does, it will fly apart, cause the arms to fly apart because that's under pressure. You got a little bit of water pressure there at the base, and then it will begin to flow water. On the top right, with your liquid filled glass bulb, this liquid, once it heats to a temperature, it expands to the point where it will overcome and break the glass. Then the base will, because it's under pressure, will fly apart and water will begin to flow up against the deflector. And then on the bottom is chemical pellet. The very top of that you see you have your pellet that's everything's fused together. And again, when this meets a certain temperature, it degrades and it will come apart, and then the base will come up off of there because it is under pressure, a little bit of water pressure, and then the water flows and deflects off the head. Your deflectors, are attached to the frame of the sprinkler. They create a pattern of discharge, a pattern of water, if you will, depending on how they're shaped. The pressure forces water up against the deflector, then converting it into that spray or that pattern. The direct flow of water downward, regardless of its orientation. The deflector will spread it out in the proper pattern. Common orientations that we see, one on the top left is the upright. Another one is a pendant, which is usually coming down out of a ceiling. Oftentimes, especially in hotels, you will notice the sidewall, and you can see the deflector there is different. It is intended to aim down because they're usually up higher. You may also have a recessed heads that can be concealed. In the lower left, this is what you see. If you see these little circles that in the ceiling, it is a concealed and recessed sprinkler head. When it goes off, it pops the escutcheon out and water begins to flow. And you also may have in-rack flush mount, like we see in this slide on the lower right. In your sprinkler room, close to your panel should be a sprinkler storage. These are usually near the riser control valve and in that room. They can be in the fire command center room with the panel as well. System control valves are equipped on every sprinkler system. Basically, they stop the supply to the system in order to replace sprinklers, perform any maintenance, or interrupt operations if necessary. Most are required to be the indicating type and manually operated. So it tells you it's open, it tells you that it is closed. This indicating valve, again, at a glance, it shows the words open or closed, basically. Indicating valves could be the OS and Y, outside screw and yoke. Whether you see the threads of the screw part there or not tells you whether it's open or closed. The wall indicating valve or wall PIV has a window that has open or closed. PIVA doesn't have open or closed window, but it has the flapper on the top that it tells you in according to which position that it is in, whether it is open or closed. And then we have a post indicating valve or PIV that does have the window on it as well. Each of these in these photographs has a electronic tamper device or anti-tamper device, and it's wired to it. You can see the little boxes that are sticking up or out. That's what that is. That tells you whether tells the system that it's been closed or it is open. With our operating valves, we may have an alarm test valve, which is located on the pipe that connects the water side of the alarm check valve to the retard chamber. This can be used to simulate the system's actuation and give us a good test. The inspector's test valve is located in a remote part of the system, same size orifice as a sprinkler basically. This is used to simulate activation of one sprinkler head, and the water normally discharges out to the outside of the building. And then the main drain valve. On every riser, you'll have a main drain valve. This allows the sprinkler service personnel to drain the water down for maintenance. This can be used to check the system's water supply as well. Water supply, a minimum supply has to deliver the required volume to the high sprinkler at residual pressures of at least 15 psi. The minimum flow depends on hazard to be protected, the occupancy, and the contents. Public water system connections, a good source has adequate volume pressure and reliability, and often the only supply that is available. Automatic systems typically equipped with water flow device that indicates an alarm when water begins to flow. And you will also hear what's known as a water flow gong. If you hear this as you pull up, rest assured water is flowing when you hear the gong, because these are mechanical. They don't gong unless water's flowing through them and discharging onto the outside of the building. So you know that the system is flowing water. Some systems may be equipped with an auxiliary fire pump. This ensures that the adequate water pressure and volume will be maintained, especially until we arrive on scene to supplement that supply. This is powered by electric, diesel, or steam, pump driven. The pump controller activates the driver and the pump when the pressure falls below a predetermined level. So if a head pops and it begins to flow water, that pressure will then drop. You now have a flowing pressure, and that will activate. Once it drops below a certain level, will activate the pump. Connections, fire department connections, department pumper connection, or the FDC can provide additional water and pressure to the system. This is what we connect to. Usually it's a Siamese inlet with at least 2.5 inch connections, the female connections, or it could be one large diameter connection such as 5 or 6 inch hose. And we use this to supplement the pressure. We'll hook into it with the pumper. We can then boost the system to help maintain that proper PSI. Minimum again of 2.5 inch or larger hoses should be connected. Whenever possible, pumpers supplying attack lines should operate from hydrants connected to mains other than the one that is supplying the sprinkler system, if at all possible. Check valves and ball drip valves. Your check valve will prevent water from flowing back into the FDC. This allows water from the FDC to flow into the system. Proper flow direction is usually indicated by an arrow on the valve or by observing the valve casing. The ball drip type may be installed at the check valve of the FDC. This is designed to keep the valve and the connection dry and operating properly during freezing conditions. With a wet pipe system, these are used in locations or areas where the temperatures remain above 40 degrees Fahrenheit at all times. This is the simplest type of automatic system. It requires little maintenance. It does contain water under pressure at all times. These are connected to public or private water supplies, and an open sprinkler will immediately discharge a spray and activate the alarm. In a dry pipe system, the system is not charged with water at all times. And in these systems, it'll have pressurized air in the system, if you will. And then at with your dry pipe valve, it is designed once if a head opens and the pressure then drops within that decrease in the air pressure is what causes the water pressure will then overcome that in the valve, and it will open that up. Again, dry pipes are used in locations where piping may be subjected to temperatures that are below 40 degrees. All pipes are pitched or sloped to help drain water towards your main drain. Air or nitrogen under pressure is in the piping above the dry pipe valve in a dry system. So a sprinkler activates, the pressurized air then escapes, which could take several minutes in a very large system. The dry pipe valve opens to permit water into the system, the pipes. A quick opening device must be installed in systems with capacity of over 500 gallons. Your deluge systems and their components, all of your heads in these are open, and so there will be a water pressure switch. You'll have a deluge valve. This can be also manually operated, and you may have electronic detectors that are tied into your valves. And so when it either detects or is manually triggered, it will then charge the system and all heads will flow at the same time. In this type of system, because all of the heads are open, there's no water in the distribution piping before the system is activated. All sprinklers open all at the same time. Again, water discharges from all the sprinklers simultaneously. The deluge valve controls flow of water into the system. The fire detection devices in the area control the operation of the deluge valve. These are normally installed in high hazard areas or occupancies. Quick supply, large volume of water or extinguishing agent is needed to the protected area. Partial deluge system, only some of the sprinklers are open. And you may also have a water curtain system, which is designed to provide exposure protection as well. Pre-action systems, you have there's a check valve, automatic heads. They're closed, sprinkler heads, and you have a combination of water pressure, atmospheric pressure, and air pressure. These are used when preventing water damage is a critical thing. They will not discharge water into the sprinkler piping except in response to smoke or heat detection in the system. The release switch opens the deluge valve and permits water to enter the system. Water only discharges through the sprinklers that then have been activated. Special systems, wet chemical, dry chemical. We have clean agent systems, carbon dioxide systems, water mist and hybrid systems, and even foam systems. The wet chem and carbon dioxide systems you may find in kitchens with cooking hoods. Standpipe and hose system. This provides a means for rapidly deploying hoses and operating fire streams at locations remote from the apparatus. And these can be found where an authority having jurisdiction may require them. The horizontal standpipes reduce time and effort needed to manually advance hose lines and can reduce the amount of hose needed to reach sprinklered areas as well during overhaul and firefighting operations. We find standpipes and these type of hose systems in many high-rise buildings, usually in the stairwells. Primarily means for manual extinguishment, also used for overhaul, the essential part of the building's design. They may be used by firefighters or trained occupants. If they have hose systems and obtainable valves, they can be used by trained occupants as well. Water supplies, reliable source may be in place, may be provided or augmented by the fire department using the fire department connection. These systems may be a part or separate from the sprinkler system itself, water spray systems, water mist, or foam systems. They are required in many buildings. They do not take the place or lessen the need for the sprinklers. The sprinklers are the most effective method for control until the fire department arrives. Common standpipe system components: the FDC or the fire department connection. They may have pressure regulating devices that are in line, risers, a water supply, may have a hose station, and water flow control valves. With a Type 1 or a Class 1 standpipe, these systems are designed to be used by suppression personnel that are handling larger hose lines. Usually this is a 2.5 inch connection or a hose station that is attached to a riser. 2.5 inch may be equipped with a reducer that allows for connection of 1.5 inch couplings. A Class 2 system, sometimes referred to as house lines, are designed for the use of trained occupants or the fire department personnel. They are equipped with 1.5 inch hose and nozzle. stored in a hose rack type system as you see in the photograph, and typically use single jacket hose and are equipped with lightweight twist type shut-off nozzles. One of the problems that we encounter with this type of system is they don't get used rarely at all, and oftentimes over years the hose will dry rot and become inoperable. Oftentimes they're also damaged by vandalism and occupants of the buildings. These can be found in apartment buildings, and this is one of the areas that is heavily damaged. And when we inspect and we look at apartment buildings in these common areas, when we find these, we should also inspect these hose systems to see if they are operable. Class 3 standpipe systems combine the features of Class 1 and 2 systems. These provide 1.5-inch hose stations to supply water for use of trained occupants. They provide a 2.5-inch connection for the use of the fire department and those trained in handling heavy streams. These must allow Class 1 and Class 2 services to be used at the same time. So we'll have a connection, but yet the hose station and the hose in the hose station is operable both at the same time. Types of standpipe systems: automatic wet systems contain water at all times, and they cannot be used in cold environments. Automatic dry systems contain air under pressure to maintain the integrity of the piping, and the water is admitted through a dry pipe valve upon opening of the hose valve. So it'll work a lot like a dry pipe system. Semi-automatic dry is attached to a water supply capable of supplying the system demand at all times. It requires activation of a control device to provide water at the hose connections. This is designed to emit water into the system when a dry pipe valve is activated at the hose station. Manual dry systems: there's no permanent water supply. These are designed to have water only when the system is supplied through the fire department connection. And then we have manual wet. They're maintained full of water, no water supply. Water is maintained to identify any leaks. Fire department must provide water to the system as well. Some buildings have smoke management systems. These systems are designed to remove smoke and control the spread of smoke within the building. They may reduce inhalation injuries and fatalities. They may reduce smoke damage as well. Most are designed for life safety purposes, but may be intended to protect property. They may route smoke away from escape routes or refuge areas, such as stairwells. The function of your smoke management system: again, maintain a tenable environment in egress areas during evacuation. You find these systems a lot of times in stairwells. They'll pressurize the stairwell to keep the smoke out. If smoke doesn't enter, then it is exhausted out. They function as a control and to reduce migration of the smoke. Provide conditions outside the fire zone to assist personnel in conducting search and rescue operations and locating and controlling the fire. And they may contribute to protection of life and the reduction of the loss of property. Parts of the overall fire protection system. We see these especially in high-rise buildings. We may see them in covered malls, buildings with atriums. You may also see them in warehouses with high-piled storage. Your smoke management system may provide compartmentation of the smoke. We can block it off. We can move it in different areas, cause a pressurization in the building, and then allow for the exhaust of the smoke. There also may be smoke barriers installed, and exhaust fans and vents pre-installed into the building and the system. And this all will help us either move smoke, remove smoke, or pressurize in areas that we may need it. Any effort to change the pressure in spaces adjacent to the fire area to help compartmentalize or exhaust smoke from the area of its original origin is called controlling smoke. So with these systems, you may have a pressurized or a passive. With passive systems, barriers with sufficient fire endurance are there to protect against the spread of fire and will help control the smoke. In a pressurized system, we use mechanical fans and ventilation to create a pressure difference across the barrier to prevent the smoke from infiltrating to a high pressure side of the building. And so these work well, and we want to keep smoke out of the egress areas. So an example in a high-rise building, this would be the stairwells. Now, in buildings that do not have this, we do have older buildings and multi-story buildings that don't have these systems. Then we use our positive pressure ventilation fans, and we may even use more than one fan in tandem to achieve what one of these systems would do. We may use a zoned smoke control setup where it is designed to limit the movement of smoke from one compartment to the other. We can kind of get it to go where we need it to go. And dilution. This is in areas such as atriums and highway type tunnels where fresh air just all at one time dilutes in contaminants to accessible level for humans to breathe. We get that good air in, bad air out. Exhaust method uses mechanical ventilation to collect smoke at its highest point in the largest space. And an opposed airflow method is used in large spaces where smoke migration is limited by an opposed airflow. High velocity air aimed at an area or fire origin keeps smoke from migrating into the unaffected areas. Smoke control stations provide firefighters full monitoring and manual control of the system and the equipment and the zone. So that would allow us to pick and choose and control where we need it to be controlled and where not. Non-permitted or unapproved modifications to structures and roofs. Non-permitted or unapproved modifications could be or can inhibit effective ventilation and can increase the risk of fire extension and structural collapse. Unapproved modifications, removal of load-bearing interior walls, pillars, and or columns would be an unapproved and a hazardous type modification. Any removal of roof supports, installing HVAC equipment on or under roofs or in attic spaces that are not designed to handle that. Storing heavy contents on the roof support beams or in attic spaces. Removing or modifying automatic ventilation systems or their components, and removing or modifying code required fire detection and suppression systems. And one thing we got to remember, people will in situations will modify buildings without the proper authorities knowing. So even though they may be required to obtain a building permit, they don't do so, and then what's out of sight or can't be seen out of mind, these modifications then get made. Altering any attic spaces into living spaces that where you don't close off, properly can be a hazard. Removing fire stops from wall cavities, installing or alternating interior wall arrangements that affect airflow patterns, removing interior doors or sealing exterior openings. Sealing basement ventilation openings up as well can be a hazard. Making any penetrations into fire stops or firewalls and also installing unapproved rain roofs. Next, that brings us to inspections. Um, when we do inspections, in the areas and the places that we're allowed to do inspections, we should uncover these modifications. Surveys can help locate and alert code enforcement personnel to changes in the structures. You do periodic surveys, you see a change or there is a notable change in occupancy and changes in the structure. This can be communicated to code enforcement or a fire marshal. Impossible to monitor all the modifications made in single family residential structures. This is where a lot of permit processes, although they may be required, who's going to know if you made a modification inside your home? Um, it's just hard to follow that because we're not doing inspections and surveys in residential homes. Those are strictly voluntary. Site sketches and diagrams. We want to make sketches and maps, drawings, and photographs. These will show a great deal of information as part of pre-incident survey documentation. Including as much information as possible will enhance the survey content, and it helps the fire department out. Some of the information on our site plans and with our maps. Again, we want to note building construction, any fire protection systems and where those connections are located. Uh, if you've got a floor plan, we want to know where the alarm panel rooms and those things are located. What the occupancy is, any fuel loading, any special hazards that may be noted as well. With our diagrams and sketches, we want to locate location of entrances and exits that are essential. Large occupancies or complexes may have site maps with common map symbols. We also may be able to obtain these site maps in digital format, especially today, and have that emailed to us so we can attach that to our plan. For buildings where the maps are unavailable or may be outdated, then include a simple plot plan drawing that shows the general arrangement of the property, and the same thing with your floor plans. Note important features and information that might affect any of the tactics that we use. Drawings must be accurate. Google Map or other aerial photography sites may also be a help to get an aerial view of the property. So this on our plot plan you can use an aerial photograph, and then you can, especially like with Google Maps, you can take a screenshot of this. You bring it up, zoom it in, take a screenshot, and then you can add the words hydrant, main entrance. You can add all these nice things, FDC, and put them in red or different color formats so you can easily look at it and go, okay, that's where that's at. Okay, that's where that's at. Common floor plan symbols will show a type of construction, thickness of walls, partitions, openings, roof types, any parapets or other important features. And important fire protection features should be included, such as the fire protection systems, locate where they're located at. Any water mains, control valves, and other important features of those systems. Many departments will use GIS or other electronic mapping programs to ensure the accuracy of everything. Laptops, notebooks, and tablets are now being used and are very helpful for recording notes and drawings of the sites and floor plans. Like I said, now, if they have these plans already in electronic format, they're able to send them to you. You can bring them right up onto the notebook, laptop, or tablet and integrate that right into your plan. NFPA 170 is our code for uniform fire safety symbols, and then follow any SOPs for symbols and other formatting. Photographs and videos, take if the owner or operator permits it. So we do want to ask for permission, and most folks are not. The things that we're taking pictures of for the incident survey and pre-plan, Most owners and occupants don't mind that, but do ask for permission. Capture any details that cannot be shown accurately in drawings. Most useful when developing pre-incident operational plans. Aerial photos are very useful, and they're most effective for planning the response. It'll show you where you can pick out where your hydrants are, where your apparatus placement may be, and those kind of things. Adjoining buildings, elevated towers, or aerial apparatus can be used again to take aerial or elevated photographs as well. Interior and close-up photographs can help make pre-incident plans complete. Video or facility can be useful for training purposes.